Hey there, welcome back. In this video, we'll talk about the difference between efficient portfolios when short sales are allowed versus not allowed. So let's see what that means, right? This far, why don't we open up the spreadsheet that we completed last time, March 24th, portfolio models complete. And we found, we were set up to find an optimal portfolio, right? So let's look at that using Solver. Suppose we've got a risk limitation, risk limit of maybe something like, how about 9.5%? 9.5%. What is the optimal portfolio? Given a risk limit of 9.5%, it's the one with the highest average return, right? So let's maximize portfolio expected return by changing these weights subject to a couple constraints. Let me just find the best spot for this. Subject to a couple constraints. One, that the weights sum to 1, as usual. And 2, that the portfolio standard deviation, maximize portfolio expected return, and then add a constraint, right? The second constraint, that the portfolio's computed standard deviation is less than or equal to 9.5%. We click OK and we solve, and what ends up happening is I get about 40% in stocks and 60% about in corporate bonds. Right? And so let me just go back to the Solver dialog box. One of the assumptions that's built into our model is that we don't let any of the weights be negative, right? So a negative weight means shorting an entire asset class, right? So short sales involve borrowing an investment that's not ours, selling it, and then repurchasing it at a later date. And if the thing goes down in value, then we make money, right? So Investopedia has a great passage on short sales if you want some more context on that. So we're prohibiting short sales in our model right now. If you look at this box down here, make unconstrained variables non-negative. So the unconstrained variables are the weights, right? By checking this box, we're forcing Solver to say, oh, all the weights have to be greater than or equal to 0, right? So that means no short sales. If we uncheck this box and then hit solve, we'll get a portfolio, and here's the weights I got. Right? We've got a negative weight in 10-year treasuries, meaning we're shorting 10-year treasuries. And it's pretty uncommon to short an entire asset class. So I think it's pretty a good practice to prohibit short sales in our optimization. But it's important to understand how the efficient frontier changes when we allow short sales, right? Allow or prohibit. So here's the chapter 12 presentation, some of the things we've looked at before. And here's how it looks, right? The efficient frontier, if we see no short sales are allowed, the blue line looks like that. And then if short sales are permitted, it sort of expands the efficient frontier. Remember, moving up and also to the left for a given level of risk is good, right? So if we allow short sales on this part of the efficient frontier, we can get a little bit higher expected return, right? If we short an entire asset class. So it's a function of the assumptions of the model. On the exam, I'd be ready to find an optimal portfolio with or without short sales. And the only difference is you either leave the box checked if we want no short sales, right? All weights greater than or equal to 0, or uncheck the box if we allow short sales. And we can have some weights less than 0. Good. So that's that. One more thing on the limitations of this mean variance optimization that we've done, finding efficient portfolios. We've used a sample of data to estimate historical average returns and then variances and covariances. And so to the extent that like actual realized returns differ from their historical averages, this model can be very sensitive to sampling error, really, is what it is. So that's why we often see some pretty extreme weights like this. And I think it's just important to be aware that, even though this tells us what the optimal portfolio is, it doesn't necessarily mean that we should go out and, for example, long 28.7% of S&P, long 92.7% of 10-year corporate bonds, and then short 21.4% of our portfolio in 10-year treasuries, right? It's pretty extreme because the model can give some extreme output. So just something to be aware of. Now, in terms of preparing for the exam on Tuesday, March 31st, I would be ready to build a spreadsheet like this from scratch, right? So all this stuff down here, actually, we're actually not going to end up getting to. But everything we've filled out, I'd be ready to do, right? Given historical return data for 3 or 4 asset classes, I'd be ready to build the R matrix and the variance covariance matrix, and then find some optimal portfolio with or without short sales. I'd be ready to do both of these things that are identified here. All right, minimize portfolio standard deviation for a given return objective, or maximize expected return for a given risk limitation, a given standard deviation. I'd be ready to do both of those things. So that'll involve finding R, variance covariance matrix, and then using Solver to optimize. So there's opportunities to practice. I guess what I would do is go back to this blank spreadsheet, the original version under in-class exercises, and then maybe try to build it from scratch yourself. Here it is, portfolio models. Get the blank version and try to build it out yourself. Or another thing you can do, what I pulled was historical monthly returns for the student investment fund. And we've got 17 stocks. And I've got the R matrix already. I found the historical average return for each of the stocks. But you could find the variance covariance matrix. Here's S, right? 17 by 17 matrix. And then if you wanted, right, given some weights, the weights are set up now to be equally weighted portfolio. Compute this portfolio's expected return and variance and standard deviation based on the data and based on the covariance matrix that you come up with. That's a good way to practice for the exam. Even better, and maybe kind of illuminating or interesting, would be if you use Solver to optimize the portfolio weights, saying based on the historical data, right? If we look at the average return across all the stocks, it's about 0.25% per month. So this is monthly data, right? So one thing that could be interesting to do is, given a portfolio's expected return objective, suppose it's 0.25% per month, what's the optimal combination of stocks? What's the optimal combination of weights for this portfolio? So that's just another way to prepare for the exam. So I would focus on building out R, X, and the variance covariance matrix, and using those to find optimal portfolios with and without short sales. That's what the second exam is all about. All right. So look forward to talking to you soon. If there's anything I can do to help you out to get ready for the exam, just let me know. And thanks for listening.